Would you like to know how to get what player types on a keyboard as an input for your game, and maybe check it against a desired word to create a simple typing game? Well, this is what we are going to look at in this tutorial. I am Peter, and welcome to the Sunny Valley Studio tutorials. Taking part in a Kenny game jam was a lot of fun, and it gave me idea for this tutorial. I strongly recommend you go to the submission section of this game jam on itch.io and take a look at the submissions, maybe to find a good idea for your own game. Okay, so first of all, let's check out how the tutorial game works. Let's see. We can hear some sounds. We can see the screen is changing, and we can see the letters we input are shown here. So if we input M, come on, we hear that the input was good. If we put letter Q, there is a bad input. If we finish the word, we can hear the sound that we have typed a good word. Let us take a look at our setup. Our game will not be as fancy as what you saw before, but with a proper setup, you can create whatever you want with this typing mechanic. So we have canvas that will store a panel that will have a hint text, so type word, and input text. It will be the text component that will take our words and check against what we type and change this its content against how well are we doing. And we have a game manager. So game manager has a game manager script that takes data as an input file, a scriptable object, some audio clips, just a way to make things a little more like a game, and an input handler and an audio source. One more thing is that we have a resource folder with a text file of English words. So this is a text file of some most common 500 words that happens in English language, and they are just separated with a space. It is very important to have a resource file called like what you see on the screen, because this is a Unity folder that it takes care of when you build your game. So let's take a look at our game manager. You can see that our code is structured a little bit differently from our previous tutorial, and that is because I wish to show you a little bit more about solid principles and design patterns and how to structure your code to be more maintainable than just simple one class with input. Let's take a look at the game manager. Let's ignore the audio clip type for now. Let's focus on file data. So basically, we don't pass the 500 words text file to the game manager, rather than we create a special serialized object. So it's a object that stores data, and we can easily create it from our Unity editor because we have used create asset menu to mark that editor right now knows that if we click create, we have resource data and words, and it creates us our new instance of scriptable object. It is a very good practice to create scriptable objects to store your data. Okay, so that's out of the way. We have our text asset word file. So this is where we pass our text 500 words text file. And also we have text asset type. So what is it? Well, basically we can pass the text asset as a text, JSON, HTML, and couple of more types of files. And because of this, we might want to create a different parsers to get what it is in your file and parse it into a list of words that Unity can accept. And that is why we have the text asset type. I will show you how we use it a little bit later. And we have the text asset word file and text asset type, resource type public fields, public properties, and those are private to maintain a little bit of encapsulation, because we now can delete the set method, and now we only can get those values. We don't change the values inside this file, so we will be safe against some changes that are unwanted. So let's see our game manager. We have our file that is the data, and what we are passing here is this file that we have created by clicking create resource data word data, just because we have passed a create asset menu directive above the class name. We pass it file name word asset data, so this is the name that the file will be created with, and menu name what you have saw before, so create resource data word data. Let's take a look at the game manager. We have some private fields. Queue of string. So this will be the queue that stores all the words that we have read from the file containing the words. Text asset reader. Text reader. So what is it? Well, basically, following the solid principles, we should pass to the high level class, so game manager, only the most basic component, most basic class that contains only what the high level class needs to know. So the game manager only wants to know how to read file. It doesn't bother with how you read the file, and that is why we have created an interface. It enforces that any class that inherits from the text asset reader must implement read file. And let's take a look how it is used. So we just create text asset reader factory that creates our concrete text asset reader class instance with the text asset reader factory. So let's go into the factory. Text asset reader factory is an example of a factory pattern. Basically what it does is implements a static method text asset reader create reader. So it returns text asset reader. And we know that text reader is an implementation of text asset reader. We are using the factory pattern to make sure that we can call create reader and pass in the text asset type that we were passing in the file data that we have given to the game manager. Here it is, resource type. And we use the factory pattern to ensure that we create our new instance of text asset reader. So return new text reader here. And why would we do that? Why wouldn't we just call if statement in the game manager? So if if resource type is resource type.text, well, we create the text reader, and if not, we create something else. Basically, it is a good practice because we ensure that anytime we call this create reader, it calls this code. So in case we have more types, or in case we need to change something, we can all change it right here. And I will enclose a link in the description to a video that explains even a better implementation of a factory pattern. But basic concept is this, that if we have only one place that creates those instances, we can easily modify the code to change how it works for small projects. But if you have much more those types to come, you might want to check the video I have mentioned that explains a little better how to create a more robust factory pattern implementation. And just to finish things up, that is why we have created text asset reader. So in case we want to create more parsers, so we want to pass in the text files, HTMLs, XHTMLs, or any type of other text file that contains our data, we just create a new concrete implementation of iText Asset Reader, create new case here that will call the create new our specific reader type and pass it back to the game manager. So to summarize it, we create all of this to ensure that our code is maintainable and we have only this one place to change if we want to implement a new parser, and our old code will still work because our old cases are still here, so nothing breaks, we just add more. Okay, so text reader is a concrete implementation of iText Asset Reader. So all we know is that this must have the read file method. And we have it. We have the read file method that returns a queue. But all it does, it takes a string array of words and calls the resource file text split. So as I have shown you before, our text file contains words that I separated with space. And that's exactly what we are doing in the text reader. We're splitting the text in the file into strings divided with a space. So its new char 0 represents the space, and we return something called prepare words. And prepare words is a method that is specific for text reader, and you would have different implementation of this in your other readers. And this is why this is important to create this kind of structure, this kind of architecture, that you don't really need to know anything. The game manager doesn't need to know anything but the create reader method, and your text reader or any kind of other reader will implement the concrete implementation, what you want and how you want it to be created, and parsed the text asset that you have passed here. So we have prepare words method that simply takes all the words and takes only the words that are length 4 or less, and creates a list. And we even shuffle those words, so every time you play the game, the words will be shuffled. So we simply create a new list just for safety. We loop through the list we have passed, so the words that we have created, the new list of words that are only 4 characters or shorter. And we take the string temporary word, so the first word, and create a random value, random number in range of I and the word counts, so the length of our list. And we swap the randomly chosen word for the word on a position first or any other through the iteration. And because we take random range I to word count, we are sure that the first word was done and it is never changed any further. We go further, we take only from I to words counts, so we get the shuffled list. And because we want to keep things safe, we have created temporary list. I'm pretty sure you could just instead use words list to change the words assigned to lists indexes and just return it or reference it. But I did it this way. So we return the temporary list that is shuffled, and we save it at as the word max 4 letters list. And we return the new queue created from this list. So this is all the text reader does. So let's get back to Game Manager. As I said before, we are calling the read file method from the text reader that turns our data words file, so the file that we have passed into our data file, data scriptable object, and we read all the words into a new queue that we have created here. So another thing we need is typing manager. Let's go and see how it looks like. So in a nutshell, typing manager just check how well the player is playing the game, how well he's typing. We have a linked list of characters. That is the current word. So a linked list is a structure that allows us to take the first or last letter from the list, in this case a character, and also allows us to remove first or last letter from it. And this is useful in our example because first we have we are creating a typing manager. As you can see, it is not a mono behavior script, and also we are using system and system.link. I will explain why next. We use a set new word to set our word passed from the game manager. We get the get next word method, and we save it as a linked list of characters. And here there is a method that checks character, taking the input character that the player has inputted just now, and checks the current word first, that value. So this is what I was talking about, the linked list. It allows us to take the first position in the character list and check it against the input character. We then remove the first word. So this is again another method that is useful here. So we remove the first letter and return true, or if the character isn't valid with the first word, the first letter that we want to input, we return false. We also check if the word has finished. So did we type all the letters by calling current word, so linked list dot count less or equal to 0. And the last thing we have is to get the current word. To get the current word, we use string.join because we know that the linked list contains characters, and we are using toArray. You don't have this method unless you import the link library. The system is redundant here, so we don't need to implement it. So we are returning string.join, and this is a separator. So we don't have any separators. We want to connect all the letters to create a word, and we get the current word to array. So this method join requires an IEnumerable type of structure, and linked list isn't that, but array is. That's why we need to convert the linked list to array before we can call join on it. As I said before, we are getting the next word in the game manager by creating the typing manager equals new manager, because it is not a mono behavior class, it is a simple helper class, and we call get next word. And get next word is just queue.dq, so take the first element from the queue and return it. Next, we have also something called UI manager. The audio clip, audio source and audio clips aren't important in this tutorial. I will explain them at the end. So UI manager is a class that we have added to the canvas element. Let's see, UI manager, and UI manager just takes the input text, so the text element that we want to modify when the player inputs the letters. We have that, the input text. On awake, we make the singleton from the UI manager. We use the singleton pattern. Well, there are a ton of ways you can use the UI manager by calling get component or find object of type. I like to use singleton pattern. So basically we create a public static UI manager field called instance and make sure that on awake in every scene we confront if our UI manager was already existing by checking instance equals null. If it was not, then we call instance equals this game object, so this UI manager. But if by any chance we create another UI manager, we want to check if instance equals null, but we know it doesn't. And if instance isn't this object, so if we have more than one UI manager, we destroy the additional UI manager. And we can call it like this, UI manager.instance, but instead we could find object of type UI manager and call the same function. Additional method in UI manager is update text, which simply takes the string text and calls input, so our text field dot text equals text. If you don't have the text, you must import using Unity engine.ui. And as you have probably seen, we have many classes with small amount of code, and that's exactly what are solid principles about. We split the code so each part does its own thing, and the game manager doesn't have to worry about how to update UI. It just knows that there is a UI manager and it can call update text if it wants to update text. And we are here calling typing manager.getCurrentWord, so we discussed it a little bit earlier. So we just get the current word that was passed to the typing manager. Below the UI manager call, we have the exact same thing, find object of type input handler. So let's see how input handler works. Input handler is another monobehavior class, which is applied in the game manager on the same object as the game manager, as input handler. And what it does is just reads the input that the input character that the player has inputted by using for each character C in input.inputString. So that basically returns the keyboard input entered in this frame. And because we're calling it every frame, we're getting just one letter. So we might be looking to get something more, like a backspace, to maybe call a pause menu. But all we care about is to check if character that we have input is a letter. So we can get the C and we put it in char is letter C. So if we know that the character that we have inputted is letter, we can safely check it against our word. Basically what we call is input char.c. We don't need to save the character, but maybe we want to use it later, so we can have a private char field input char. And we here do something strange we call onCharacterInput. What is onCharacterInput? Well, there is something called event action, and that is array type of structure or a list type of structure. So how it works? Well, basically we take the action character, so a method that takes character as an input, calling it listener, and plus add it to the listener. So like we would add to a list another method. I will link in the description a video explaining better what delegates are. We have created a list of methods, and what it will do, every time we have inputted a character, it will call all the methods that are stored in this onCharacterInput. Basically, we are calling assign onInput check player input. And this method takes the character, as we said previously, the input handler passes a char in its action call, so it's in its delegate, and because check player input is passed as a delegate, it takes the character C every time it is called, every time the player types character. And because of that, we have a debug.log, just to just show how it is working. And you can see that update is empty thanks to that. We just rely on the event firing of the check player input. And further, we just call typing manager.check character. We have discussed this method. It just checks if the character is valid against the word that we desire to check against. We call UI manager instance update text because this method returns a bool value. So we know we have reduced the number of letters that we need to input, and we want to show the player that he did good. So we reduce the words, the first letter we deleted. Typing manager check if word is finished. So we know that at some point we have inputted all the letters. And we can say that typing manager set as new word get next word. So basically we take the next word from our queue and set it as a new word for the typing manager to check against. We play feedback sound. So that's what was I telling about the audio source. It is unnecessary in this tutorial, but it makes the game so much more fun that you play and you hear what you did wrong or right. And at last, again, if we have set a new word, we want to update the UI manager instance update text. I'm pretty sure this method could be rewritten, refactored to maybe be a little better, but that's what it is right now. Okay, and last thing that I have even forgotten about is that you might have a case that the word is not in lower cases and the type manager doesn't know that, and the character really depends on what letter you have inputted. So if you have upper letter, you need to input upper letter. So we should probably set here in the typing manager to lower to ensure that we always have the lower letter words. Well, if you otherwise desire, you can set it up differently. So again, let's take a look how the game works. Take a look. You can hear the sounds are playing if we put in the good letters and finish a word. If we put a bad letter, we can hear the bad sound playing. That's it for our tutorial. I hope you have learned something today. If you liked it, please check out my Patreon site. I enclose link below. And if you like it, please leave a like. If you have any questions, please leave a comment and I'll be sure to answer you. And thank you very much for watching. Goodbye.